Three particles of unknown charge are placed at rest in a uniform electric field as shown. The acceleration of each particle after being placed in the field is indicated. What is the sign of the electric charge of each particle? Let's sketch this picture ourselves. Here we see that we have a uniform electric field. What we mean by uniform is the electric field is constant. What reveals the fact that the electric field is constant in magnitude and constant in direction is the fact that these field lines are all parallel and equally spaced. Let's look at charge A. Charge A is accelerating in a direction that is parallel to the electric field. Let's go ahead and label the electric field E. And let's also assume that the only force acting on charge A is the force due to the electric field. Since the acceleration of charge A is in the same direction as the electric field, what do you think must be the sign of charge A? Is it positively charged? Is it negatively charged? Or is it neutrally charged or has zero charge? Well, charge A must be positively charged. The reason why it must be positively charged is because we know that a positive charge will experience an electric force that is parallel, that is in the same direction as the electric field. Since the only force acting on charge A is due to the electric field, we know that charge A must be positive since it's accelerating in the direction of its net force. Let's look at charge B. Is charge B a positive charge, a negative charge, or has zero charge? Well, since charge B has zero acceleration, we know there is zero force acting on it. And if there is a charge in an electric field, it will experience an electric force given by this relationship. So since that object at point B is not accelerating, that object must have zero net charge. What about particle C? Notice that the acceleration of particle C is opposite to the direction of the acceleration of particle A. Also notice that the acceleration of particle C is opposite the direction of the electric field. Since the only force acting on particle C would be from the electric force due to the electric field, and since it is accelerating opposite the direction of the electric field, we can surmise that charge C must be a negative charge. Because remember, a negative charge will experience an electric force opposite the direction of the electric field line.